y'all, it's Dr. Know-It-All. So happy probably day after Thanksgiving. I have a reason for this. I'm recording this Thanksgiving morning, but I wanted to make sure that I had people's attention, and I figure Thanksgiving in the United States at least will be very busy. Also, this episode is basically going to be kind of leftovers. So I'm going to do a collection of extra notes from Full Self-Driving, both 10.69.3.1 and also version 11. So I've done episodes on both of those before, and I'll put links to those at the end of this episode so you can see the other things. But I wanted to touch on a couple of new things. So I'm going to start with 10.69.3.1. There were two extra notes that were put in for the 3.1 release that I didn't have in my 10.69.3 release notes. So anyway, those are showing right here. So we've got, the first one is introduced foundational support for model parallel neural network inference by sharing intermediate tensors across SoCs or system on chips to improve road edge and road line prediction consistency through changes to trip compiler, inference runtime, and interprocessor communication layer. That's a lot of stuff, but this is actually kind of an important thing. This note is talking about how Tesla is basically turning their Full Self-Driving 3 computer board, which has two FSD chips or, whatever, trip chips. Anyway, it has two of these things, and they're turning it into a multiprocessor system in a more efficient manner. So people have talked about this before. This is like the strongest evidence yet that they are actually offloading, some of the work onto each processor as opposed to doing it all on one processor and then having a completely redundant processor. So part of this is the fact that they're just running out of compute power in this FSD 3 in the hardware 3 that they have in all the Teslas right now. So when hardware 4 comes out, they may be able to go back to doing this on one and have full redundancy. But at present, it looks like what they're doing is they're splitting up the work. So foundational support just means like baseline support for model parallel neural network inference. So the inference just means it's runtime. They're not doing any training, but model parallel means instead of data parallel, instead of splitting the data into two and feeding it down the same, down the same thing, down the pipe in parallel fashion, they're actually splitting things up into model parallel. So the actual neural networks are parallelized. So it's like, I guess, program parallel, if you want to think about it that way. But, this is neural network architecture. So anyway, they're parallelizing this. And then what they're doing is this sharing intermediate tensors. So each thing does its own calculation, some level of neural networks. And then they have a very fast way of sharing the tensors that they calculate, which effectively means that they don't have to recalculate each of these things themselves. They can calculate a piece of the puzzle each, and then they can put it together. The intermediate tensors, if you don't know about that, me and Scott Walter did a whole thing about a primer for Andrej Karpathy, and you can watch the first, I think, 15 or 20 minutes of it. I'll put a link to that up here if you're interested. But anyway, tensors are pretty much critical to the way that neural networks work. And so what they're able to do is get partly done and then share the tensors and then improve the work that they're able to do in terms of road edge. So it's like predicting where the edge of the road is and road line prediction consistency. So that's actually a good thing, right? You don't want your road suddenly flickering and having things change and all of that kind of stuff. So the way that they're doing this is they're making changes to the trip compiler. So that's the trip chip that they're using to actually do the inference and everything. And they've changed the compiler, obviously have made it more refined and specific to what they're doing. And so they've optimized the compiler essentially. And the compiler is the thing that turns the high level code that humans can understand into machine code that the computer can run really quickly. They've also improved the inference runtime, which just means that they're able to do this faster and better. And they've also improved the interprocessor communication layer. So that's obviously through software since they can't change the hardware. But so you've got these two chips on the FSD 3 hardware 3 computer, and they've obviously improved the ability of these things to crosstalk between themselves as this thing is working. So this is a big deal. This should actually make things go faster, and the foundational level of this means that they should be able to, amortize this over other architectures as they need to, but it also does completely, in my mind, prove that they have given up on the idea of redundant chips. They're just using both of them to the max capacity that they're able to do, which is fine. It doesn't seem like these chips crash very often. And again, My personal opinion is that robo-taxis are not going to be allowed with hardware 3. They're going to require hardware 4, and that's just going to be something that Tesla, it's not even a regulatory thing, it's just Tesla's going to be like, if you want this thing to full self-drive you around, that's fine with hardware 3. If you want a robo-taxi to make money, or if we release this to the fleet, it's going to be done via hardware 4, so it's not going to be an issue. So anyway, I just think this is a really interesting note, and that's why I wanted to make sure that I brought that up. Okay, the next thing is improved handling of traffic control behavior in dense intersection areas. This is that lane language thing that John Emmons talked about, and I'll put a link to that up here if you're interested in that. But this is that language where they're taking the 3D scene and they're turning it into a linguistic thing, and they're actually creating a grammar. But anyway, they're improving this by the association logic between traffic lights and intersections. So what they're doing now is expanding this out. They did a note before where they included some of the lane markings in the middle of the intersection to improve this. And now they're taking this one step further, and they're actually including the lights. And you can actually utilize the lights to figure this out. If you see 2 of those red left turn arrow thingies that you see, or green or whatever color it is. But anyway, if you see 2 of those traffic signals that clearly indicate that that's a left-hand turn, you can see that before you can even see the lane markings. So you know those 2 lanes are going to be left-hand turn lanes, right? Or the same thing with a right-hand turn, or straight arrows or other things. So by associating the lights with the lanes, you can make earlier predictions and more confident predictions. So that's actually really, really cool. So yeah, so that's the 10.69.3 update. And again, if you didn't see the other release notes, definitely check out that video, which is linked at the end. And now let's turn to version 11. All right, and on to version 11. So I'm going to skip these 2 again because I already did this, but the big thing, this is all about the highway. Pretty much the entire sequence of notes is. So anyway, they've enabled FSD Beta on the highway, big deal. They've also improved occupancy network's recall for close obstacles and precision in severe weather conditions. Again, we talked about that. Check that out in the other video. And here we go on to new things. Improved merging behavior by leveraging lane geometry and lane bounds, association with course map information, and better gap selection algorithms, allowing for a smoother and safer experience. Okay, so merging behavior, obviously this is when you have lanes that merge into each other, and I would imagine also lanes that split or something. But anyway, what they're doing is they're improving this. You can get to the end where it says smoother and safer experience, which is excellent. Very, very nice to have the smoother and safer experience. If you've done this before, merges sometimes are a little violent as it goes back and forth between lanes and things like that. But basically the way they're doing is they're leveraging the lane geometry and the lane bounds. So they're looking at the way this whole thing is constructed, maybe using the language of lanes, but I'm not sure. And then they're also associating that with the course map information, which would be the stuff they're getting from Google. They're taking the Google Maps, which says there are 4 lanes in this area, and then there's a merging lane. So they have information about this, and they're associating that with what they're seeing, the lane geometry, what the ego car is seeing. And of course, better gap selection algorithms. So basically it's saying you can be over to the left when you have a merging lane scenario instead of being dead center. I'm sure if you've driven full self-driving beta or enhanced navigate on autopilot, you're used to that thing where when you get the extra wide lanes, the car puts itself right in the middle. That's not the correct place to put itself. As the lane merges, you should be to the left. And then the lane closes down on you, so you're already in the right place. So anyway, this should improve the way that human beings experience this all. It wasn't particularly dangerous in the past, but it was very off-putting as a human to be like, move over. The car would be in kind of the wrong place, and then at the last minute scoot itself into the right place. So this should definitely help humans to feel more confident with the full self-driving, which is a lot of, I think, what Tesla is doing these days, is helping humans feel more confident so that we don't feel the need to disengage the autopilot. Next up, and like I said, a lot of this is about the highway, added highway behavior to offset away from blocked lanes and generic obstacles, cool, like road debris, while also adding a smooth handoff between in-lane offsetting and lane changing. So the obvious things, blocked lanes, so that would be emergency things or potentially stop traffic and stuff. But I think this one's particularly about see the traffic cones and you have to get over to another lane, or also obstacles in the road like boxes or tires or ladders or whatever it is, or things that it doesn't even know because it can use the occupancy network. But anyway, to get away from those things, but then also to be able to do that within the lane. So let's say there's something at the very far edge of the lane and you can just kind of scoot around it. So that's an in-lane maneuver around an object, and then we're getting to out of lane. So if it's like, oh, that's blocking the whole lane, like it's a big tire in the road and I need to get out of the lane. And so it will actually move into the other lane, and you're getting this smooth handoff, whatever that means, between the in-lane offsetting and lane changing policy networks. So you've got two different policies going on, and it's able to hand that off. So basically the in-lane one goes like, this is too much for me, lane change, you take over. Lane change goes, thank you very much, it takes over, and it figures out how to get around this. So again, this is particularly on the highway, so this should make highway behavior should feel substantially more modern and a little less clunky. Like the old version of it was very, very, as it said in the release notes for version 11, the very first one was, this thing is like 4 years old. The old version of the software that all of us are still using who are not on 11 are still using that old version of the software. And it's very clunky at points. It's very mechanical. So this should allow the thing to feel much, much more human and to behave better and to avoid obstacles and stuff, which is a big deal. Like on the highway, you don't want to hit something at 70 plus miles an hour. Next up, we have improved speed-based lane change decisions to better avoid slowing down traffic in fast lanes and interfere less with navigation. So the interfere less with navigation, yay. There's this weird thing with the old version where it just would constantly, well, it does, it just constantly switches back and forth in lanes on the highway. So that's really, really annoying. Now, this doesn't specifically say highway, but I'm going to assume a lot of this will happen on the highway, but also we'll get some on city streets as well. But basically, it's going to be like, I'm going to improve how I decide to change lanes, and it will then be able to move around slowing traffic in fast lanes and things like that. So, right, so if you see a line of traffic coming up that is slowing down substantially, rather than braking and then trying to make the lane change, my assumption is here that what it'll do is it'll smoothly change into a less occupied lane so that it has more freedom and it doesn't have to slow down as violently and things like that. But the other part about this is hopefully it won't do this unnecessarily, because it really is annoying when it interferes with navigation, when it's just like doing this thing where it's like going back and forth and you feel like kind of an idiot because you're like, wow, everybody's looking at me going like, why is this car changing to the fast lane, then changing back to the slow lane, then back to the fast lane again, things like that. So hopefully that will improve behavior again and make us humans feel less like we need to intervene. Again, I think this is a big part of what's going on right now, is making us humans more comfortable with full self-driving, make it feel more human so that we have to intervene less, because the fewer interventions we have, the more data Tesla can show to NHTSA and other regulatory bodies that this is a really, really viable technology. And I think they're at that stage now where they're actually beginning to think about that. They're like, okay, we have to create a data set that clearly shows that this is better than than an average human driver. So that's what they're setting up for. So I think that's part of it, is if you can make it more comfortable for humans, we won't intervene as much. And the consequence of that is that you get more intervention-free drives and therefore more data to show that this stuff is actually working. Interestingly enough, the very next note is the opposite of this, which is reduced sensitivity for speed-based lane changes in chill mode. Now, I use assertive mode because that's just the kind of driver I am. But for those in chill mode, you probably don't want the car like constantly bopping around back and forth between lanes. You just want it to be chill. So what this does is it kind of intercedes with the last note above, and it goes like, okay, fine, the lane is slowing down, but I'm just going to be chill about it. Just stay in my lane and not worry about it. So that's what I assume. So there's just kind of a knob that they've basically, you can turn up or down to enable more or less aggressive, not aggressive, but assertive lane changes. Next up, we have improved lane changes to allow higher jerk maneuvers if required to stay on route or to move away from lane blockages. So remember, jerk is the derivative in time of distance, right? So you got the first derivative is velocity, the second derivative is acceleration, the third is jerk. But again, just for us, it's that jerking motion. So what it's doing is it's allowing more jerk to stay on route or to move away from lane blockages. So again, this is the kind of thing where it like sees something, it's like, oh crap, I'm in the wrong lane, or there's road debris, or I need to move over here, or something like that. It's allowed to do more violent maneuvers to make that happen. And a lot of times you can see the car will start to do something like get into a lane it needs to, and then kind of bail out because it's just doing it too gently. And so what this is going to allow, what it should allow, is for the car to be able to go like, oh, I need to get into this lane. There's a gap. I can do it, but it's going to require a little more aggressive maneuver, and I'm just going to make that maneuver happen. So I think that's very important. Higher jerk is a really important thing. It sounds like, what's that Steve Martin movie, The Jerk? It's like it's like the sequel to it. It's called Higher Jerk. But anyway, I think that the higher jerk maneuver maneuvers are really going to be good. As I've said previously, the problem with neural networks is they tend to average things. They tend to like soft things, not hard things. So what you do is as you're training and too much acceleration laterally or longitudinally gives you a negative score, you get a loss in your loss function. And what it'll do is it'll tend to really, really mellow that out. And so what they're doing is they're counteracting that now by saying like under certain circumstances, this is not a loss. This is actually a good thing if you use a little bit higher jerk. So that should be a really, really beneficial thing for us drivers. Again, it should give us more confidence in what's going on with Tesla. On to the last two now. First, improved smoothness at highway lane splits by being less strict about centering between lane lines and allowing lower jerk maneuvers where safe to do so. So again, we're back to the highway, and this is that thing where you have multiple lanes where it either splits into two or merges down into one, and so you effectively have an extra wide lane for a period of time. And like I said previously, what happens is, before this, the car would stay right in the middle, and then as the lane would close down or when it would split or something, suddenly the car would go boop, and it would move into the correct place, but it would do it very violently. So again, this is that jerk motion. That's that thing where you're just like suddenly the car goes zoop, and it just moves into this spot, and it doesn't feel comfortable. It doesn't make us passengers, us monitors of the system, feel very confident about it. So again, this is that thing where when it's safe, the car is going to attempt to get into the correct lane, do the split early, do the merge early. It's going to be in the correct place so it doesn't have to do a violent maneuver. So that is all to the good, and that again should make us humans feel much, much better so that we don't have to intervene in the drive. And finally, we get reduced latency of trajectory optimization by 20% on average without sacrificing behavior by leveraging numerical tricks for more efficient computations. So trajectory optimization, obviously your car, you want to optimize its trajectory so it doesn't do that, the classic thing with the older versions of full self-driving where it would go like that and kind of do these maneuvers in little pieces, and it would feel very awkward and everything. And of course, the jerk maneuvers, the high jerk, low jerk, all of that kind of stuff. It's optimizing that so that you get a better, more comfortable experience. So again, this is that kind of consistent theme going on with these notes, is more comfort for the monitors and more comfort for the passengers. This is going to make my wife exceptionally happy about that. Anyway, but 20% on average is a big deal. That's a better optimization. It just means that it's optimizing, it's doing it more efficiently, it's doing it faster without sacrificing behavior. So they're clearly distilling some of this stuff down into a simpler version of things using numerical tricks. I have no idea. Again, they're not going to tell us. That's their secret sauce. So they're not going to tell us what those numerical tricks are, but they've done some sort of cool numerical tricks to make the computer more efficient so it can do these computations in a more efficient manner, and therefore you get lower latency on your trajectory optimization without having to sacrifice the accuracy of the trajectory optimization. And what this should do is, again, lower latency should cause it to feel better. If you have high latency, that's when it does something and then it decides that was wrong, and then it does something else and it decides it was wrong and it does something else. So you get that sort of jerking motion as it's making decisions. But if you reduce the latency, you get to the point where you don't have to worry about that anymore. It just, it's much smoother because you have lower latency. So all of that should be really, really beneficial. All right, so that's what I've got for you today. I think this is actually incredible notes. So again, we've got multi-processor things they're using on the Inference engine with hardware 3. That's really cool. A lot of new stuff for the highway, and then a whole bunch of stuff for the comfort of the people who are in the vehicle, which should make us less likely to do things like take over and feel like we have to intervene with the vehicle. So we can more comfortably just monitor the car as opposed to feeling like we have to take over and drive it. So all of these are amazing. Supposedly version 11 went out to some actual people last night. Elon said before Thanksgiving, and today's Thanksgiving, so it should be out there. I haven't seen it, but we should be getting version 11 very, very shortly to the rest of us. I'm loving 10.69.3.1 in the meantime, and I'm going to pick up my son in downtown Washington, D.C. So I will be, he's taking the train in to come visit us for the day. So anyway, I'll be utilizing that to get downtown, and that should be a lot of fun to try out anyway. So to my U.S. friends, I hope you have and had a lovely Thanksgiving day, and you're having wonderful leftovers today, and you can enjoy this video as you're eating leftovers and enjoying the England-United States soccer match. Fingers crossed about that one. I don't know. It's going to be a tough one. And in the meantime, everybody have a lovely day, and I'll see you in the next one. Bye-bye.